In this video, we're going to continue going through some exercises where we continue to refine and practice finding limits both graphically and numerically. So here in this problem, we are asked in problem 1 to numerically estimate the limit of x minus 4 over x squared minus 3x minus 4 as x approaches 4. Right? So our x value, we see that right here. Our x value is getting closer and closer to 4. So we're going to choose values on either side of 4, plug those in. We're numerically estimating that, so we're creating a table, and we're going to see what happens. Does it appear to be settling down on a specific value? So we'll have our x value, have f of x. We're choosing values on either side of 4. So we'll go 3.9 and 3.99, maybe 3.999. At 4 itself, we don't know. All right, so if we were to take 3.9 and plug 3.9 into our function, then our output is going to be something like 0.204. Plug in 3.99 and we will get 0.2004. 3.999, we'll get 0.20004. So, I don't know, maybe we have an idea of what that looks like it's heading towards. Maybe 0.2. Let's see if that seems to be the case from the right-hand side as well. So if we were to plug in 4.1, we'll have 0.196. And then 0.1996. And then 0.1996. And there, it also appears as if our function values are getting closer and closer to 0.2. So it appears as if this limit is approaching 0.2. So that was a numerical estimate. Problem 2, we are also asked to numerically estimate a limit. Here we have the limit of sine of 2x over x as x approaches 0. So we will take values of x that are a little bit larger than 0 and a little bit smaller than 0. So negative 0.1. Negative 0.001, no, 0.01, and negative 0.001. 0 itself, we don't know. And 0.1. So if we plug in negative 0.1 into our function and evaluate that, again, make sure you're in radian mode, but we would get something like 1.9867. Plug in negative 0.01 and we'll get 1.9999. We have 2 there. On the other side, we'll get 1.9867 and 1.9999 and 2. So what does that limit appear to be when we plug those values in? Well, on either side, from either direction, our y values, our function values, are getting closer and closer to 2. So as our x values approach 0 from either side, the y values appear to approach the same value of 2. So those were two numerical estimates. The next problem asks us to graphically estimate the limit. If we're going to do that, we need to draw the graph. So this is a piecewise defined graph. For values of x that are smaller than 0, we have an x cubed plus 1 graph. So an x cubed graph is going to look like this. So that's x cubed plus 1. And then after that, we have a cosine graph for values of x bigger than 0. We have a cosine graph. So that's what our graph looks like. As we approach from either the left or from the right, the y value on both of those, both to the left and right of 0, that y value is getting closer and closer to 1. So we would say the limit, as x approaches 0, of f of x is equal to 1. The y values are approaching 1. Great. And then finally, we have the limit as x approaches 1 of the absolute value of x minus 1 over x minus 1. And this picture, if we were to draw that, we have our x value approaching 1. If we have values that are smaller than 1, so negative 1 or 0, or then on the top, the absolute value is going to get rid of some negative stuff after we evaluate that. X minus 1 would be a negative value. When we take the absolute value, we'd have a positive. That denominator is going to be exactly the same thing, except for it's going to be the negative of it. And so when we take that ratio, we will just have negative 1 itself. If we have values bigger than 1, then the top and bottom are going to actually be exactly the same value. And so, as we approach 1 from the left, then we are going to get negative 1. Right, so if we have our x values are getting closer and closer to 1, but they're approaching from the negative side, the left-hand side, then our y values are staying here pretty close to negative 1. If, on the other hand, we have a limit as x approaches 1 from the right, so we have values of x that are 1 plus a little bit more, then our function value is heading towards 1. This number, negative 1 and positive 1, are not the same thing. And so this limit right here, as we approach 1 without regard to side, we will write it does not exist, DNE. So in order for a limit to exist, it actually has to approach the same thing from both sides. Now, that's the first time we've seen a limit that doesn't exist. In our next video, we will talk more about limits that do not exist. We will see you there.